Problem number 4. The first 5 terms of a sequence are shown below. If the sequence continues in this manner, how many squares will there be in the 10th term? And how many squares will be shaded? Alright, so we're assuming this is 1, and this is 2, and 3, and 4, and 5. The 5 terms. So let's actually make a table and see if we can find a pattern. Alright, so I'm going to make a table, and this is going to be n, the term number. So we'll have 1, 2, 3, 4, and 5, because we have 5 terms. And then, let's see, the next column I'm going to make the number of squares. Okay, so this is going to be the number of squares, and this is going to be the number of shaded squares. Alright, so let's list these out and see if we can find a pattern. Alright, so in the first term we've got 1 square and 1 shaded. Alright, in the second term, what have we got? We've got 5 squares, and we have 3 of them shaded. The third term, we have the original 5 plus 6 more, so we have 11 total squares. And it looks like we have 4 more shaded squares, so this is going to be 7. Alright, so in the fourth term, basically it's the third term, but then we have 8 more squares, because we have 4 on the top, 4 on the bottom. So that's going to be 19. And let's see, number of shaded squares, we added 2 on the top and 2 on the bottom, so that's 4 more, so we have 11. And the fifth term is basically the fourth term with 5 more squares added to the top and the bottom for 10, so this is going to be 29. And and we added 6 more shaded squares, so this is going to be 17. Alright. Well, you can tell we've got some kind of a pattern. Here we start with 1 and we're adding 4, and then we're adding 6, and then we're adding 8, and then we're adding 10. Okay, so you can actually see it here. This is the difference between those terms is 4 and 6 and 8 and 10. So it's the consecutive even numbers starting with 4. All right, so you can see we have a pattern. So now one thing I know based on other math that I've done is that this is sort of there's a method of finite differences, and so if you look at the difference between consecutive terms, you can see these aren't constant, but you can see the next finite difference between the differences. So there's a difference of the differences. These are all 2, right? And I know that if the second difference is constant, then you have something involving a square. So what I did to solve this, I thought, okay, in terms of the square of n. So I know that, for example, this is a 1 squared plus 0. This is 2 squared plus, how many more? Just 1 more. This is 3 squared plus 2. And this is 4 squared plus 3, and 5 squared plus 4. Okay, so it looks like it's the square of n plus n minus 1, and actually that works. So the nth term, the number of squares is equal to n squared plus n minus 1. Okay, and I just did that by inspection. There's other ways that you can come up with, with the pattern, with the equation for the pattern. And the other thing that you could do, since there's only 10 that we're looking at, you could actually list out the 6th, 7th, 8th, 9th, and 10th terms. It wouldn't be that hard, would it? You just have to add, here you added 10, now you have to add 12, and then 14, and then 16, and so on. And then you could come up with what the 9th and 10th figures how many squares would be in that figure. So we can do it either way. First of all, let's see. If we had 10 The 10th figure would be essentially 10 squared plus 9, which is 109. Okay, that's by using this equation. And this way we'd get what? We'd have to add 12, which would be 41, and then we'd have to add 14, which would be 55, and then we'd have to add 16, which would be 71, and then we'd have to add 18, which would be 89, and then we'd have to add 20, which is 109. So either way we get the same thing. Alright, so the number of squares is 109. Now let's look at the number of shaded squares. You know, again, there's a pattern, right? So let's look at the finite differences here. So it looks like we added 2. So we went from 1 shaded square, we added 2 more, 1 on each end. And then here we added 4. So 2 on the top, 2 on the bottom. So to go from 3 to 7, we added 4. But then here, let's see, we added, is that wrong? No, then, yeah. No, that's right. We added 4 again because we had an even number of, we added an even number of squares, so we had, we added 2 again to the top and the bottom, so we added 4. And then we added 6. And we would add 6 again, and then we would add, okay, so that would be 23. And then we would add 8. And we get 31. And then we'd add 8 again, and we get 39. And what term are we up to? 1, 2, 3, 4, 5, 6, 7, 8. Okay, we gotta go 2 more times. Then we add 10, we get 49, and then we add 10, and we get 59. Okay. So the number of shaded squared is going to be 59 if we do it this way, where we look at the pattern and then continue the pattern. So now, as far as an equation for that, I didn't come up with anything for that. But you know, essentially you're adding. You have 1, and then you add 2, these 2, then you add 4, and then you add 4, and then you add 3, and then you add 3, and then you add. What am I doing here? Wait a minute, 6 and 6. Hang on. So then you add 6, and then you add 6. Alright, that brings you up to the 6th term. And then you add 8, and then you add 8. That brings you up to the 8th term, and then you add 10, and then you add 10. That brings you up to the 10th term. And you can just add those numbers up, and you will also get 59. Okay? And you might notice too, when you're adding these are, you know, there's like an interlaced arithmetic series here. So you can look at, you know, 10 and 10 is 14, or sorry, 4 and 10 is 14. 4 and 10 is 14, 6 and 8 is 14, 6 and 8 is 14. So it's, you can kind of add quicker that way if you just take, what is it, 4 times 4 times 14 plus 3, because you got this 1 and the 2 here. That'll give you 59. Or you can just make 10s. So I see there's 10, 10, so that's 20, 30, 40, and then that's 16, it's, so that's 56, and then another 3. So any way you want to do it, you can add it up. It's most of the time when you're adding things like that, it's good to look for nice pairs of numbers to make your addition easier. So anyway, the answers are, we'll have in the 10th term, we'll have 109 squares, and 59 of them will be shaded. So there you go.